As usual, I will only include classes and methods that are relevant for our tracing purpose. In this case, we are not going to include the details for entry class and also the product class because we have done their tracing in the earlier video. So what do we have? On the one hand, we have the JUnit test case, specifically test refurbished shop 1. And also we got a refurbished store class as well. Over here we got attributes, and also we got the various methods. I'll go over them shortly in a bit. And I also prepared some visualization which can save our time. So these are the diagrams you're supposed to know how to draw from the earlier videos as well, for the entry class and also for the product class. I'll build some pointers from scratch, but for the attribute values, they are already filled in. Okay, let's now take a look at the refurbished store class very quickly. Let's see what we have over here. Number one, we actually got the 3 attributes together with the constructor for creating an empty refurbished store. Okay, so that's what we have. And remember to visualize the to visualize the store objects at the runtime, we only need the entries and also the NOE. We don't need a constant. Okay, we don't need that. Okay, because it never changes its value, so it's not worth tracing it. And also we got our constructor here, and we got 3 accessor methods that will be important to trace their return values, namely the get number of entries, get private entries array, and also get entries. And we also see some dot notation that's complicated in a moment as well. Okay, so that's the second part. And the third part is about the 3 overloaded versions of the add entry method over here. I'm going to use different color to actually indicate the different objects that they're going to involve creating. Okay, the first one is going to be this one, the add entry version, which will take an entry objects. And the second version is going to be this add entry method version, where it will take a string serial number and products objects. And finally, we got a version over here that will take the string serial number, the string model, and also the double original price. So we got these 3 versions over here. You can really see that this fragment of code, somehow by calling this method, will eventually before that we need to set up the entry like this. And in order to call this method, we also have to set up the entry and product like this, and etc. Okay. Let's now go over the test case line by line and see how we can trace it. Let's now start with the first line over here. So the first line is about creating over here. Let me use orange. The first line over here is about creating an empty store over here, and store is referenced into variable rs. Okay, so how do we create it? So we're going to call the default constructor, which is defined over here, and that one there we already, oh sorry, it should be here. And then it is actually going to initialize an array of entries of the maximum capacity, which is 5, and also it's going to assign the value NOE to be initially 0, right? That's going to be the 2 initialization steps that we're going to perform. Okay, let's now do it. So rs is going to be the variable, so I would say rs, the variable is now going to store the address of some new refurbished store objects at the runtime over here. Okay, let me now put it. So it's going to be refurbished store. Always remember the title of the box corresponds to the type of the objects. And then we got 2 attributes over here. We don't show the constant, just the attribute value, the variables. So it will be the entries and also the NOE, right? So it would be entries and also NOE. Okay, what's going to be entries? This.entries, of course, this will just be rs. rs.entries will be initialized to be an array of size 5. So it's going to be pointing to the beginning of an array of size 5 over here. So it's going to be 1, 2, 3, 4, 5. And indices will be 0, 1, 2, 3, 4. And initially, what should be their values? Well, they will be all default values without pointing anywhere. So we'll be pointing to null, we'll be pointing to null, we'll be pointing to null, and etc. Okay, let me just say, okay, just for completeness. All of them will be pointing to null. And what about NOE? NOE will just be initialized to be 0. So that'll be the value 0. Alright, so that's about what this line, the consequence is. Okay, this is a consequence. Hopefully you're okay. And then let's now go on to actually set up the entries and add them. We got 3 entries to add according to our test case. Let's take a look. The first one, I'm going to use blue. And it's going to be about this part over here is going to set up the entry and the products, right? So what we're going to do is we're going to, this is really something that we have traced earlier, so I don't need to repeat the exact details. I just want to show you what the final diagram looks like and also highlight the pointer changes. P1 is going to point to some objects with iPad Pro 12.9 original price, space gray, 1000 for storage. It supports cellular connectivity and also discount value. So this is the object I just created over here. I just put it here, right? Exactly the attribute value I just mentioned over here. Okay, exactly those values. And then it's going to be pointed by P1. So P1 will point to this particular product objects, right? And then when we set entry E1, E1 is actually going to point to an entry object. I'll say this is the object over here. The serial number will be this serial number here. It's going to be F9 FDN. F9 FDN over here, right? Start with that and etc. And what about the products? So this is really important. I want to review it. So since we passed P1 over here, so that means E1 dot product is going to point to wherever P1 is pointing to. That's how we set it up, right? We talked about aliasing in the earlier video. So now in this case, it's going to E1.P over here is going to point to wherever P1 is pointing to, something like this. Okay, so that's the blue box. Okay, and then let's now take a look at the new method that we want to trace, which is this guy here. Okay, how do we trace this line? rs.addEntry E1. How do we trace it? So to trace this line here, we know that we are calling this overloaded version of the add entry, where the context object is simply rs. So every occurrence of this will be replaced by rs. And then what's the also rs over here? Okay, and then every occurrence of the argument e is going to be replaced by e1, right? It's going to be e1, and this will be e1 as well. So what it boils down into is the following line. Let me write it down. rs dot entries, I'll just say es for short, at position rs dot noe. rs dot noe. In this case, it would just be the initial value 0. Is assigned to e1. And you know how to interpret this variable assignments for the reference variable. And also the second line will be rs dot noe plus plus, which means it should be incremented. So now how do we execute these two lines? To execute this line over here, let's see how we can do that. rs.entries, rs.entries, which will refer to the beginning of this array over here, and we want to go to this particular index. rs.noe is referring to 0 at the moment. So we want to go to index 0, and then it should point to wherever E1 is pointing to. E1 is currently pointing to this object over here, right? You can see that's E1. So that means this slot over here, rather than pointing to null, is now going to point to this particular entry. Hopefully you're following the logic, right? Let's now do it. So we are saying that index 0 over here is now, rather than pointing to null, is now going to point to wherever E1 is pointing to. So that's what's going to happen. Okay, that's about the rs. And then one more line, which is easy to forget. Also rs.noe plus plus. Okay, that means we're going to say rs.noe incremented from 0 to 1. So just to remember the second purpose for the NOE, which is to indicate the next entry to be added where it should be stored. So that should be index 1. Okay, so what's going to happen is we're going to change this value from 0 incremented to 1. Okay, so that's the complete execution of this particular line over here. rs.addEntry E1. Hopefully you're following. And let's now move on to the second entry, which will be done in a similar way, but we better be careful, okay, when we trace it. So the second one will be, here we want to create again as before the products and also just the products, which will be P2, okay? And in this case, we don't create an entry. Entry will be created inside the addEntry method, which I explained in the earlier video, but we also trace it. Let's see the green box. What's that going to be? We're going to have a product storing product object whose address will be stored in P2, and then we got iPad Air 649, gold 64, false for connectivity, and also 100.00 for discount value. So that's exactly these values I have just put in for the attributes, just for our convenience. So, and then this will be, the address will be stored in P2. So that means I'm going to put P2. Okay, P2 over here is pointing to this particular objects over here. Okay, and then let's now execute the this line, rs.addEntry, and with a serial number and also with P2. Let's see what's going to happen, right? So here you can see P2 is the reference to some products. And what we are executing is this overloaded version of the addEntry. That's what we are executing. And then every occurrence of the P over here is going to be replaced by P2. And this will also be replaced by P2. Okay? And what we are doing is we are actually calling addEntry, which will take a new entry. So we are really calling again this version of the addEntry method. That's why we said we're calling the helper method, right? So that our code doesn't smell. That's what I mentioned in the earlier video. But now, how do we really trace this particular line? Okay, very briefly speaking, what's going to happen is this expression here is called anonymous objects, which means we're still going to create a new entry object over here whose products will be pointing to wherever P2 is pointing to, and that's exactly this entry object over here. However, since it's anonymous, it's not going to have a name. And what's going to happen is Java actually has a way to keep track of this internally, so we don't need to worry about exactly how to do it. What's going to happen is this particular entry objects, they will have some pointer that we don't really know its name, but Java will know, okay, because it's anonymous. And then when we say addEntry over here, when we call this helper method, we're going to execute exactly like the two lines that we did before. So let's see how we can do that, right? So what's going to happen is we're going to, let's use green. When we execute this, we're going to say rs dot entries, right? We're going to execute these two lines. And then rs.noe. What's rs.noe at the moment? It should be 1. Okay, at position 1 is assigned to, and now what's this E1? So rather than E1, we don't really have a name. We just have this, right? If you don't mind, let me put a star over there, so just that you will know I'm talking about this particular address. I'll just say star. It's not really valid Java syntax, but just conceptually you will know what I'm talking about. And also after that, we're going to say rs.noe++. So the second time we're executing these two lines. So how about this line over here? So we're going to say rs.entries, which points to this beginning of the array, at position 1 is now going to point to wherever this particular object is pointing to, right? Which is a star. Okay, let's now do that. So position 1 is actually over here, and then rather than pointing to null, it's now going to point to wherever this object is, this entry objects. And of course, for that particular entry object, we also need to set its product to be P2, which I definitely should do earlier. And that one also will be pointing to here, wherever P2 is pointing to. Okay, and again, I put a star here simply means it's anonymous objects corresponding to this new expression. So we don't really know what the address is, so we cannot refer to it programmatically in our program. But Java at the runtime, they will have a way to keep track of that, which we cannot know. Okay. All right, so that's about the second entry, and let's now do the third entry addition, shall we? So the third one is going to be just this pink line over here. you can see we don't have any entry objects created, and we don't have any product object created at this point, but it will be created internally. Let's see exactly how. So we're calling add entry over here, and then we got serial number over here. We got iPad Pro 10.5, 929. Eventually, what we will get is this particular product objects, iPad Pro 10.9, and also 929, and also the actually that's it. And all the other attributes will just be default value. We spoke about this in the earlier tracing already. Okay, let's now see a little bit more closely how exactly this can be done. So when calling this, RS will be the context objects. So we're calling this. So this will be replaced by RS. And then this anonymous object expression is even more complicated, but it's not too bad. This is some anonymous product objects. So this is some anonymous entry objects. So we don't really know their addresses, so we cannot really manipulate them. However, Java will keep track of them without any trouble, but we just cannot know what they are. Okay, you can definitely study a little bit more into this expression, but what's going to happen is we're again calling this add entry method over here the third time, and then we're going to execute a very similar two lines, which I'm not going to write out once more. Okay. So what's going to happen is if we follow the same logic, and by the way, in the previous one, I definitely I forgot about executing this line over here, right? You can see this line, which means after inserting the second entry, I'm supposed to increment further rs.noe from 1 to 2. Right? It's really important. So this 2 is telling me that in order to insert the next entry, I am supposed to go for index 2 rather than index 1. If I go for index 1, that means I'm simply just wiping out the effect from before, which is not correct. Okay. All right. So by executing this, what we will do is we're going to create this products objects and make sure we create this entry objects also anonymously. And then its product fill is now going to point to this particular products. Okay, that's not surprising. And both of these simply don't have a name. I'll say star, and also that one doesn't have a name. So I would say star, and star. Okay, it simply means we don't know their names. Right. So what's going to happen at the array level is at index 2 over here, we are going to make it, rather than pointing to null, it's now going to point to this particular entry. And don't forget, we also need to execute the increment for the NOE. So now it will be incremented from 2 to 3. Right? So after inserting 3 entries, what's going to be the story now? After inserting 3 entries into the refurbished store, the NOE will be simply 3, telling us we got 3 entries inserted already. And number 2, for the second purpose, if we want to insert the fourth one, it should go to index 3, right? It makes sense. And then what about the entries array? Because the maximum size is actually 5, right? That's how we set it up to be. So we have already occupied 3 slots. That means the remaining 2 slots are simply null. That means every time when you're trying to run a for loop to go over the array one by one, you should really say it should only up to but excluding NOE. You should not simply just go to all the way to the length -1. That's not the way to go, because when you go over this slot and this slot, they're simply just null. So you can easily run into null pointer exception, right? So that's something you will see when I run the for loop over here. Let me show you quickly. You can see here, when I try to go, let's say for the get entries, I say the loop counter should be strictly less than this.noe rather than this.entries.length. There's a reason for that, because if you say this.entries.length, then you will also look into slot number 3 and slot number 4, which are still null. In that case, you can easily, very easily run into null pointer exception. Okay. All right, so that's about adding the 3 entries. I hope you're okay. And I just want to explain a little bit about aliasing before I talk about assertion. So we got 1, 2, 3, 3 entry objects. We got 1, 2, 3, 3 product object and 1 refurbished store objects. So we also got aliasing. So can we just see one example of that? For example, you can see here, let's say for this, let me use the blue one. For this particular object over here, how many addresses, how many names does it have? Okay, how many names? To see how many names it has, you just need to see how many incoming arrows we actually got. And this is one of them. This is one, which is E1. And this is just another one that's actually, so we got aliasing. So let me write it down here. So aliasing, one example would be E1 and also rs.entries at position 0. They are pointing to the same entry objects. In that case, I would say rs.entries at position 0, right? It's pointing to the same objects of the entry. All right, so let's now go on to talk about assertions. So these are the assertions I want to go over, but I don't really need to go over all of them. I will just simply go to one from each category, and you can go for the remaining ones by yourself as exercise. Let me point out to you what you really should notice, okay? You can see for the first category over here, we are basically trying to say, over here, we got the same prefix, which is rs.get rs.get private entries array over here. That's a prefix. rs.get private entries array. And also rs.get private entries array over here. So now we should really understand what this will return over here. What this expression will return depends on how we define the method. So get primitive entries array is simply going to return this.entries. And what's this? You can see when we call that, this is simply just rs over here. Simply just rs. So this will be replaced by rs. rs.entries is just going to give us the rs.entries will just give us this particular array. Right? After this, we can do various expression. Right? Let me choose one of them and then explain to you. For example, you see rs.get primitive entries array and then at index 0. rs.entries array, which will refer to the beginning, and then we are saying index 0, which is referring to the blue, follow the blue pointer over here, is talking about this particular entry. Is it referring to the same object as E1 does? Indeed, they are pointing to the same objects. So that's why this relational operator should be true. That's why assert true should really pass. Okay, so hopefully you're okay with that. And then you can see for rs.private entries array at index 3 and 4. Index 3 and index 4, they are still pointing to null, right? As I visualized before, right? So for this part, I'm just going to explain these. For the rest, you should really try to exercise yourself by going over them on the diagram. Let me now focus on the second one, which is more challenging to understand, okay? For the second category, we got rs.get entries as the common prefix. rs.get entries over here. That's what we have, right? So how do we understand rs.get entries? rs.get entries is actually going to call this method over here, which will internally create some local array called ES. Let me draw it here. So ES, and what's going to be its size? It's going to be this.noe. What's this? This will be just rs over here, right? That's a common context object, so rs. So rs.noe is simply going to be 3 at the moment. That's a final value after we have inserted 3 entries. So it's going to be an array of size 3. Okay, and then 0, 1, and 2. And we're going to run a loop over here. And how many iterations are we going to run? Well, since counter I will start from 0, go all the way to this.noe, we know that it's 3. So go from 0 to 1 to 2, not including 3, because we got strictly less than, right? So it's going to be 0 for the first iteration, it's going to be 1 for the second iteration, and 2 for the third iteration. But exactly what's going to happen, let's now see just for the first iteration for illustration. For the first iteration, what's going to happen is we're going to get ES at index 0 is assigned to this, which is rs.entries at position 0. Let me write it down. So what we have is for the very first iteration, we're going to get ES at index 0 is assigned to, so this will be replaced by RS, right? RS dot entries at position 0. So that's what we're going to have. And this interpretation will be easy. We've done this many times. ES0, ES pointing to the beginning of this array, 0 will be here. It should really be pointing to wherever RS dot entries at position 0. RS dot entries referring to the beginning of this array at position 0 currently is pointing to this blue array over here. So this should really point to wherever it is pointing to. That's what's going to happen. And similarly, for the second iteration, you will simply got to change this from 0 to 1. For the third iteration, you will change this from 1 to 2. That's what's going to happen. Okay, let me now try to do the visualization here. So for the first iteration, we're going to say index 0 is now going to point to this blue array over here. As soon as we have done that, we can now expand our aliasing definition just earlier, right? So you can see for this particular blue object over here, we got just one more path that's actually incoming, that's actually defining that. So we can just add one more into the list. So it's going to be the local array, in this case ES, and then at position 0. Okay, basically this expression over here. Or you can, to be more precise, rather than referring to the local variable, you can say rs dot get entries. Okay, I'll say ENS at position 0. Okay, so that's so all these 1, 2, and 3. So these are the 3 names for this particular entry objects, and you can try to make some other example as well for other objects. I'll leave that to you. So that's for the first iteration for this for loop. What about the second iteration? For the second iteration, we are going to worry about index 1. So index 1 is now going to point to the green objects, right? So now let me try to see if I can draw that. Okay, so it's going to point to wherever the green object is, like over here. Okay, let me try to draw a little bit better. Okay, slightly better. Okay, that's a green one. What about the final iteration? It's going to be index 2 over here, right? And then it's now going to point to wherever the pink object is. It's going to be a little bit messy, but you can see it's actually very, very precise over here. So it's now going to point to this entry object over here. Okay, so that's about the this expression here. Okay, and then let's now just see one of them. If I try to see this particular expression, okay, this one over here, and I'm also going to analyze the expression more carefully together with you. But before that, let's just follow the path quickly together. rs.get entries, that in that case, it will be this return array, which points to its beginning. If we go to index 2, go to index 2 over here, and that one we say dot get products, right? If we go to index 2, it's really referring to this particular entry objects, and then we say dot get products, which will give us this particular products, and then dot get model, so we'll get the model over here. So once we get a model iPad Pro 10.5, we can now compare using equals to iPad Pro 10.5. So that's how you follow through the dot notation. Okay, so whenever you got indexing notation, that means you want to go to that particular slot of the array. Whenever you get dot, so that means you want to somehow look up the objects that's referred to by the corresponding address. Okay, that's what has happened. Let me now go over this complicated dot notation quickly with you, so that you will feel more comfortable writing such expressions yourself. Let's now again, we want to go from left to right. Starting from the left, if I just go for rs over here, rs has been declared of type. What type? Should be refurbished store, right? It's actually refurbished store over here. Refurbished shop or refurbished store. Okay, so this will be refurbished store, the type. Refurbished store. And then if you try to say rs dot get private entries array, for example, right? We can say get entries either way. If I say get private entries array, in that case, it will also give me back some entry array, right? But of course, if you replace that by get entries, you will also get something similar. Okay, it's the same. So that will give you entry array type. So this will be of type entry array. And then if you try to go for its index 2, right? So that means when you try this part over here, if you grow that a little bit, just this part over here. So this part over here is going to be just entry. All right. So once we get entry, so we can now say get products, right? So if you try dot get products, it's going to give you the products. You can look up the declaration for the get products method, but I can tell you that it's going to give you some return type, products. What about the get model? The get model is actually a method in the product class, right? You can see this get model is defined in the context object over here, right? So what we're going to do is we're going to just box this as well. So the get model is actually going to give you back some string type. Okay, let me just make some little bit space for the final arguments about the equals method. Okay, let me put it here. Put it here. Okay, and what about the final equals method? Which version of the equals method are we calling? Well, apparently we say equals over here, and the context objects is actually of type string. So we are really comparing string together with some other string value. You can see here the entire expression over here that we have analyzed so far up to here. rs.get private entries array at index 2.get products and .get model. So this entire expression will give you some context objects of type string, and then you're trying to invoke equals on the string objects, and you compare that against iPad Pro 10.5. In this case, if you look up the diagram, you will actually pass the assertion. It will be true. Okay, so that's about very detailed tracing of the of how we can add entries into the refurbished store. Especially, we can see how the entries array will change, and also how the NOE will change. We also speak about this particular method over here. And one more reminder for you: you should always remember it would be a no-no if you actually try to say I is strictly less than this dot entries dot length. Okay, if you do that, it is going to give you a null pointer exception. Okay, and for the precise reason, you can think about it yourself, or you can refer to the actually tutorial video I referred to you back in winter 21. Or you can just simply ask me during the Q&A. All right, so that's about the this example here, and then we'll try to develop more methods in the next video in the refurbished store class.